Hello, good morning. I'm Dr. Sonali here. We are here on Education on Cloud. For class 11 chemistry, we have a chapter named Structure of Atom, Atomic Structure. So when we discuss about, Dalton has said atom is indivisible. It is like a tennis ball which is cut, it is hollow inside. But now we have seen there are few particles, subatomic particles are discovered. So atom is not hollow, atom is divisible. It has three subatomic particles. In the nucleus there is proton and neutron, and proton is positively charged, neutron is neutral, and the mobile particle, proton and neutron are stationary, nucleus is stationary, but around that a specific energy level which is called orbitals, electron is a revolving moving particle which has negatively charged, so which will be constantly moving it. So we will see how the discovery has happened. Constituent of atom is no longer considered as indivisible. It is made up of electron, proton and neutrons. So now first we will see J.J. Thomson has discovered electrons. So electrons has discovered by J.J. Thomson from a study of cathode rays. So this is the cathode ray diagram I had shown you here. This is a discharge tube. Okay, this is invisible rays emitted from cathode in the discharge tube when the pressure of the gas inside the discharge tube is about 10 to the power minus 1 atmosphere or 0.01 mm, and voltage is about 10,000 volts is applied. Their main characteristics are, now let us see first how this experiment is. Here there is cathode, here there is anode. Now the in the discharge tube hydrogen like light gas is filled, and when the specific voltage is applied, then the gases will emit the particles. So the negatively charged particles, the particles are going towards the positively charged plate. Okay, so that is only high voltage is applied here, and we can see a green glow that side towards the anode. So it means that's what it is called. The rays are called cathode ray and the tube is called cathode ray tube. So discovery of electron is identified like that. So particles was going towards positive plate, so it is indicated the particles are negatively charged. What are the characteristics? They pass through perforated anode and produce green fluorescence on opposite glass wall. Here the green fluorescence will be there, like we can see with the color change also. So here there will be green fluorescence. Okay, and they produce sharp shadow of the object placed in the path, showing that they travel in a straight line. Okay, like this. Then we can see they can rotate a mounted mica wheel placed in their path, showing that they consist of material particles and they are deflected towards positive plate when external field is applied on them, showing that they carry negative charge. Okay, so we had just now discussed it, seeing the picture. The negatively charged particle present in cathode rays are only called electrons. Okay, so charge on electron is 1.602 into 10 power minus 19 coulombs, and which is equals to 4.803 into 10 power minus 10 ESU, or is equal to 1 unit. So mass of electron will be 9.11 into 10 power minus 31 kg, or we can say 1 by 1837th of that of hydrogen atom. Hence electron is the fundamental particle which has 1 unit negative charge and mass nearly 1 by 1837th of hydrogen atom. Any gas may be taken inside and cathode taken may be of any material. Electrons produced carry same charge and same mass. Okay, so this shows the electrons are universal constituent of all the atoms. Now we will see next is discovery of proton, which is positively charged and which stays in nucleus. So how discovery has been done? Like this discharge tube has been taken here also, and there is one perforated cathode has been taken, and we can see whenever the gas hydrogen type of light gas is passed through it and a specific voltage, what will happen? The positively charged particles which are emitted from anode, which are getting attracted towards the negative plate, like that. So now the proton is discovered by Goldstein from the study of anode ray. This is called anode ray tube, and using a perforated cathode in a discharge tube. So we are using here perforated cathode. This is perforated cathode, this is the perforation. Okay, and on applying high voltage, positively charged ions produced from the gas inside due to knockout of electron from them. These travels away from anode to cathode. They travels towards the cathode. Okay, so pass through the canals, holes of the cathode, and strike the glass wall coated with zinc sulfide, producing green fluorescence. Okay, and these rays are called canal rays or positive rays. Now they are showing the red color glow is this side. It means there is particles are coming, knocking out the electrons and coming out. Okay, so they are called canal rays, or the main characteristics of these protons are they are travel in straight lines. They made up of material particles. They carry positive charge. However, charge on the particle depends on number of electrons knocked out, and mass depends on nature of gas taken. So the smallest charge plus unit, plus 1 unit, and the smallest mass of hydrogen atom. These particles are called protons. Okay. So the proton is a fundamental particle which has 1 unit positive charge and mass nearly equals to hydrogen atom. They are only deciding the mass of an atom. Now what has happened after discovery of proton and electron? It is observed there are some particles which are neither going to positive plate nor going to negative plate, but which has mass equals to almost proton or more than that. They are considered as neutron. So how the discovery of neutron by James Chadwick? It is done by bombarding beryllium or boron atom with alpha rays. Neutral particles with mass nearly equal to proton were emitted. Okay, mass nearly equal to proton. These were called neutrons. Neutrons is defined as which carries no charge but has mass nearly equals to hydrogen atom. Now what is Thomson model of atom? Thomson has compared the atom with there are different models are given, like plum pudding or watermelon model is given. Okay, so they had compared it. There are seeds in the watermelon and there is a pulp, red color pulp in the watermelon. So it is considered as the here an atom is a sphere of positive electricity in which sufficient number of electrons were embedded to neutralize the positive charge, just as seeds in the melon or raisins. So this is compared to electrons, and this mass is considered to protons. Okay, it could not explain the result of Rutherford experiment. Now what is Rutherford experiment? That also we will see. Here there is a lead block. From that one radioactive material is kept. Radioactive material will emit alpha particles. That alpha particles will be captured on the gold foil. This is a gold foil, and this is zinc sulfide screen, and this is radioactive substance. So we will observe there are 3 types of observation. Some particles pass through it, some particles deviate to some angle, and some particles completely bounce back. Very few particles bounce back. So there are different observations. Some particle pass back means there are large empty space around the nucleus, and some particles deviates means the particles are similar charge, so they repel each other, and some particles deflect back from the so they are hitting to the solid object like nucleus, and they deflect back like that. So like this the discovery of nucleus and electrons are identified. So a thin foil of gold is bombarded with the alpha particles. Most of the alpha particle pass through foil undeflected. So a few were deflected and the small angle, while very few were deflected back. Okay, so 3 type of observation. The conclusion is there is sufficient empty space within the atom and small heavy positively charged body which is at the center called nucleus. The atom consists of heavy positively charged nucleus in the center containing all protons and neutrons, and the electrons were revolving around the nucleus. So the centrifugal balance of the force of attraction. Okay, so electrons are very light particles. So atomic number and mass number we are talking. As an atom is whole is electrically neutral, a number of protons is always equals to number of electrons. This is called atomic number. Okay, further, as a mass of an atom is due to protons and neutrons, and each has 1 unit mass, sum of protons and neutrons is called mass number. So what is atomic number and what is mass number? How it is written? A and Z. Z is atomic number, A is mass number. So for example, in case of sodium, if you see a number written here in superscript, that is called mass number. Number written in subscript, that is called atomic number. How to find out number of electrons? Number of electrons is always equals to number of protons. So electrons are 11 here. This is because Z mass atomic number, and proton is also 11, but for the number of neutrons we have to do it 23, the mass number minus the atomic number. If we do, we will get number of neutrons like this. Okay, so what are isotopes, isobars, isotones and isoelectronic species? Isotopes are atoms of same element having same atomic number but different mass number. We can see here the atomic number which is written at subscript is same, but the superscript number is different. So that is indicating they are isotopes of each other. So hydrogen has 3 isotopes: protein, protium, deuterium, tritium, like this. Okay, and we can see here also chlorine also they have shown same atomic number but different mass number. So two isotopes of chlorine, atoms of different element having different atomic number but same mass number. Now we can see here the number written here, the atomic number is different but the mass number written on the superscript is same. So argon, potassium and calcium all are here, they are isobars of each other. Okay, now what is atoms of different element containing same number of neutrons? So neutrons can be found out subtracting this. So 14 minus 6, 15 minus 7, here number of neutrons are in both the cases 8. So carbon, nitrogen, oxygen are called isotones of each other. Okay, then the species which contains same number of electrons after ionization or atomic state, they are called isoelectronic species. Like O2 minus, atomic number of O is 8 and 2 minus means 2 electrons are added, so 8 plus 2 becomes 10 electron. Atomic number of Na is 11, so plus charge means electron is lost, so 11 minus 1 is 10 electrons, so both are having number of electron 10, so it is called isoelectronic species. Iso word is used for same. Okay, so Maxwell electromagnetic wave theory, if we talk, energy is emitted continuously from any source in the form of radiation traveling in the form of waves associated with electric or magnetic field. Now oscillating perpendicular to each other, you are observing this kind of, okay, so here the electric field and the magnetic field are perpendicular to each other to the direction of radiation. All of them travel with the velocity of light. Okay, then what is wavelength? We are seeing now here the wavelength is distance between two adjacent crest or adjacent trough. Okay, that is only called, it is expressed in here Armstrong, meter, centimeter, picometer, nanometer. So 1 Armstrong is equal to 10 power minus 10 meter or 10 power minus 8 centimeter. 1 nanometer is equal to 10 power minus 9 meter. 1 picometer is equal to 10 power minus 12 meter. That is called wavelength. Okay, distance between two consecutive crest and trough. Frequency is equal to the number of waves passing through one point in 1 second. That is called frequency. Frequency can be indicated by hertz. 1 hertz is equal to 1 second inverse or 1 per second. Okay. Velocity is distance traveled by the wave in 1 second. Relationship between c, v and lambda is c is equal to v into lambda. So here we have c is velocity, v is frequency and lambda is the wavelength. Now amplitude is the height or crest or depth of the trough is called amplitude. Wave number is equal to reciprocal of wavelength. So wave number is equal to 1 by lambda.